It's time to practice what we have learned with the help of a question. How many molecules of water are there in 10 grams of ice? Also, calculate the number of atoms of hydrogen and oxygen separately, the total number of atoms and the covalent bonds present in the sample. So, there are quite a few things that you need to calculate in this question, right? Let's start with the first one, which asks us the number of molecules of water in 10 grams of ice. So, for this part of the question, we know that the mass of ice is equal to 10 grams and the molar mass of water is 18 gram per mole. Now, using the formula that we already discussed for the number of molecules, we have mass of water in gram divided by molar mass of water in gram per mole multiplied by the Avogadro's number. Putting the values in this formula, we get 10 divided by 18 multiplied by 6.02 into 10 to the power 23 gives us 0.55, and let's multiply this by the Avogadro's number and we get 3.31 into 10 to the power 23. So, that is the number of molecules of water. With this, we are done with the first part of the question. The second part of the question requires us to calculate the number of hydrogen and oxygen atoms separately, right? So, we know that one molecule of water contains 2 hydrogen atoms and we just calculated the number of molecules of water. Therefore, 3.31 into 10 to the power 23 molecules of water will contain 2 multiplied by 3.31 into 10 to the power 23 hydrogen atoms. That will give us 6.68 into 10 to the power 23. So, that is the number of hydrogen atoms present in this molecule. Next, let's calculate the number of oxygen atom. We know that one molecule of water contains one oxygen atom, correct? So, 3.31 into 10 to the power 23 molecules of water will contain 1 multiplied by 3.31 into 10 to the power 23 atoms of oxygen, which is 3.31 into 10 to the power 23. All we did was just simply multiply the number of atoms with the number of molecules of water. Quite simple, right? Okay guys, now the next step requires us to calculate the numbers of covalent bonds present in the sample. We know that one molecule of water contains how many covalent bonds? Yes, that is right, 2 covalent bonds. So, 3.31 into 10 to the power 23 molecules will contain how many number of covalent bonds? For that, you will simply multiply 2 by 3.31 into 10 to the power 23. In doing so, you will get 6.68 into 10 to the power 23, that is the number of covalent bonds present in the sample. Lastly, what is left to be solved? Well, we just have to calculate the total number of atoms of hydrogen and oxygen now, which is quite simple. Why? That is because earlier we have already calculated the number of hydrogen atoms and oxygen atoms, isn't it? All you need to do is add those two answers. We will have 6.68 multiplied by 10 to the power 23, which is the number of hydrogen atoms, remember? Plus 3.31 into 10 to the power 23, that is the number of oxygen atoms. On adding these, we will get 9.99 into 10 to the power 23, which is the total number of atoms of hydrogen and oxygen present in the sample.